Hi everyone, it's Sorkin. Today we have a problem when we are given n non-negative integers representing an elevation map where the width of each bar is 1 and we need to compute how much water it can trap after raining. So for example, in this input we have 0, 1, the elevation is 0 and this elevation is 2, 1 and so on. So how much water we can trap in this case? So this one can trap 1. This one is also 1. Here we can trap 2. Here we can trap 1. And here we can trap 1. So, and the sum of it gives us 6, which we are returning. Let's take this example and work on it. We are going to solve this problem using two pointers approach. So we have a left pointer which starts from the beginning of the array, and also we have a right pointer which starts from the end of the array. And also we are maintaining other two variables, Lmax, which represents the height to the maximum height to the left of our current position, and Rmax, which represents maximum height to the right of our current position. So when we start, we are choosing so at each point we are choosing that between the Lmax and between the current height of the value. So for example, at this position, the Lmax equals to 0, and at this position the height for the left position is also equals to 0. So we are setting this value to 0, and we are setting the value for the Rmax. The value is Rmax is 0, and the value here is 1, right? So we are choosing 1, and our value is for the Rmax is 1. So at each step we are checking if our Lmax is less than our Rmax, so then we are moving our left pointer. We are moving our left pointer, and also we are taking if we can trap at this position, right? If we can trap here water, so we are adding that to our result. So for example, at the first iteration, so what we do here, so our Lmax is equals to 0, right? Our Lmax equals to 0, and our H is HL, which means that this value, right, this height is equals to 0. 0 minus 0, it's equals to 0, so our result for now is 0. And now we are moving our left pointer. So now our left pointer here, again, at each point we are choosing between the Lmax and the Rmax, right? So we are updating our Lmax because our Lmax was 0, and so our current height is 1, and which means that we can update our Lmax, which is at this position 1. So now we are comparing Lmax and the Rmax, right? They are equal. So since our condition is Lmax if the Lmax is less than Rmax, we are going to this condition. Otherwise, we are going to the other condition, Rmax minus height of the right. So we are starting to move from here. Now we are starting to move our right pointer. So again, we are moving our right pointer. Can we trap a water here? So the Rmax is equals to 1, and the value of it 1 minus 1 gives us 0. So we are moving our right pointer, and we cannot trap a water here. So at this position, again, we are updating our Rmax because our Rmax was 1 and the current value of it 2. So we are updating that to 2. Now between 2 and 1, right? Between 2 and 1, so Lmax is less than Rmax. We are moving our left pointer here. We are moving our left pointer. And now can we trap water at this position? Yes, we can, because our Lmax value is equals to 1. So we are considering only this scenario, right? So we are considering only this scenario. In this case, what is the height of the wall to the left of this value, to the left of this position? It equals to 1, and the height of the wall on the right of this, so that's the first condition, right? So the height of the wall to the left of this position is equals to 1. So which means that so it doesn't matter whatever the height is here. It's, I don't know, maybe the height is here 10 or 11, whatever. So we can contain here only water only we can contain at this specific position, we can contain water equal to 1. That's the first condition. Another condition is, you might think that okay, so how we are sure that let's say we have so let this the left wall is 1, right? So we can trap here at most one unit of water. So how we are sure that we have a right wall here, right? Maybe so because our right is at the end of so at this position, how we are sure that we have a wall equal to or more than 1. We are sure about that because the only reason we came here, because our left max is less than the right max, right? It means that this wall, it equals, at least equals, so even let's say that at this position there is no wall at this position here, right? So our this value is equals, at least equals or less than the value of the R max. So we are, that's why we are from our L max, we are subtracting our current height, which is from 1 we are subtracting 0, and which gives us 1. We are updating our result. We are updating our result, and now we are moving our left pointer again. So we are moving our left pointer here. We are moving our left pointer. Now again, we are comparing. So now we are moving our left pointer here, and we are updating our Lmax. Now our Lmax also is equals to 2. So our Lmax is equals to 2, so which means that the height of the wall, including this position to the left of the array, so to the left of our array, and including this position is equals to 2. The same for the R, including this position, right? Including this position, the height of the wall is equals to 2. Now again, we are comparing our condition. Lmax is less than Rmax. No, they are equal, but we are moving our right pointer. So we are now at this position. We are now at this position. So Rmax is equals to 2. What is the height here? The height is equals to 1. So 1 minus 1, 2 minus 1 gives us 1. So which means that we can, at this position, we can trap 1 unit of water, right? So we are updating our result to 2. Again, at this position, we are sure that the only reason why we came to this condition, right? R max minus height, height at this position, because we are sure that our left pointer, right? It is at least equals or it at least equals or more than the current position. So it means that at this position we will specifically at this position we will contain as much, so we will contain as much water as the difference between this height, right, between this height and the difference between the whatever is the right border, so whatever is the right border, because this is the minimum one, and the height of the current position, so this difference, right, and this difference gives us 1, so we are updating our value to 2. And the same way we are moving our right pointer, and as we are at this position, right, so we are updating, so we are updating our value at this position. We are getting, so we are moving this until our left and right, so until meet at a certain position, and then we are returning whatever result which we get, and in this case we are getting 6, which we are returning. First thing that we do, we are checking two edge cases. The one is that if our height is equals to null, or if our height length is less than 2, so it means that we cannot travel water in this case, so we are returning 0 right away. And if not, then we are going to our solution, which is we are initializing our variables. We are initializing our left pointer, which is equals to 0, our right pointer starting from the end of our array, and also we are maintaining left max, the maximum value to the left of the current position, and the right max, the maximum value to the right of the current position, including the current position, and the result which we are returning. So while our left is less than our right, so we are moving both pointers. So first we are updating our Lmax and the Rmax considering the current position. So for example, considering our scenario, when we start, our Lmax is going to be equals to 0 and our Rmax is going to be equal to 1. So then if our Lmax is less than our Rmax, then we're taking the difference between the Lmax and the height of the current position and adding to our result and moving our left pointer. And the same way, if our Rmax is more than our Lmax or it equals to Lmax, in that case we are adding the difference between Rmax and the height to our result and moving our left pointer. And at the end we are returning the result. So the time complexity in this case, we are going over our array only once. It's n of n, and the space complexity is 1 because we are not using any extra space. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.